Okay, so today we're talking about theorems on the AB and BC Calculus AP exam. And we are recording this, so in case you need to watch it later, it's no problem. You can either watch it again, or if you need to leave to go somewhere else, you can just always watch it. I'll make sure I post it in both of the joint classrooms. Okay. So theorems on AB and BC. Okay, there's three main theorems, and then there's a subgroup of one of the theorems. Okay, a subset of one of the theorems. So the first theorem I'm going to talk about is the theorem that is kind of different than the others, and it's one that you use a lot. And I don't know, I don't really think of it as a theorem. There's actually two theorems that I want to show you that that are kind of important, but not the ones I'm talking about today. So let me just do those real fast. So extreme value theorem is very important. Okay, and extreme value theorem is the one that says if you have a continuous function, so it's only continuous. Okay, so if you have a continuous function, that's the only requirement. So if it's continuous and it's on a closed interval, then there exists a maximum and a minimum, which occurs at the relative extrema or the endpoints. Okay. There's also, I don't really think of it as a theorem, but it's kind of in the theorem section. It could be related. It's called the second derivative test. It's not really a theorem. But second derivative test for relative extrema. It's just one that we don't use very much, but it comes up on the AP test. It's kind of in the same category. So that's if the derivative at a number is 0 and you know the concavity. Okay, and then if the concavity is positive, then something happens. Or if the derivative at the value is 0 and the concavity is negative, then something different happens. The ones I really want to talk about today are mean value theorem and the intermediate value theorem. Those are the real ones I want to talk about today. But to me, in my brain, there's kind of 4. Okay, so this one, if you are facing up and you have a slope of 0, then that's a relative minimum. Okay, and if you're concave down, so you're facing down and the slope is 0, then that's a relative maximum. And there's examples that you can find of those probably that you've been using. And if not, send me a text or send your teachers a text and they can probably find you one. I have some specific ones that my HL students were just doing. And so I have some specifically that might help you. So if you send me a text, I could tell you which ones those are. Okay, but the ones we want to talk about today are mean value theorem, and intermediate value theorem. Okay, I'm going to draw you pictures of both of them first. And then mean value theorem has the sub-theorem that's called Rolle's theorem. Okay, but mostly I want you to compare the difference between mean value theorem and intermediate value theorem, because if it tells you to use Rolle's theorem, if it tells you to use mean value theorem, if it tells you to use intermediate value theorem, I think you're set. Okay, because it tells you what to do, you know what to do. What I find in the free response sometimes is that you're doing a question and you have no idea how they want you to justify it. And it's using one of these theorems and they don't mention it, but they mention it in the solutions. And you're like, how did they think of mean value theorem? How did they think of intermediate value theorem? And then, what's the consistency? How come it's one? How come it's the other? So that's really what I want to talk about today. So it's not saying that you don't know how to do theorems, okay? Because you learned it in your classes. It's just how does it look, and what things maybe can you help it with? Okay, so mean value theorem. Okay, mean value theorem. You have an A. I'm just going to give you the picture representations, which you've seen before. Okay, but it's nice just right before the test. And let's see, we have 39 people. Let's see if I can take attendance. Oh, I think I can't take attendance because I already took attendance and you guys were all here. But seriously, I'm so surprised that not one single one of my, I found one of my HL students. Okay, good. Well, that's good. Oh, there's another one of my HL students. Okay. Okay, good. Because you guys, this is on the AB and the BC test. Okay. Cool. Okay. So basically what you have for the mean value theorem is you have A and then you substitute it in and you get F of A. You have B, you substitute it in and you have F of B. Okay, and basically you have some curve like this. Okay, and then I'm going to use my other color. So the way I think of mean value theorem is the algebra slope equals the calculus slope. Okay, algebra slope equals calculus slope. So calculus slope, as you remember, is the derivative. So f prime of some value c. And the algebra slope is y2 minus y1 over x2 minus x1. Now, when you do it with these and with the more complicated ones, whatever is on this right side, see where it says f prime? The left side is one derivative less. So, for example, in this one, this would be f of b minus f of a over b minus a equals f prime of c. And lots of times they'll put the f prime of c first. Okay, but it's algebra slope equals calculus slope. Now, it doesn't just have to be with f's, and that's what we're going to talk about today. It could be f prime of b minus f prime of a over b minus a, and then f double prime of f is on the right side. Okay, but first I just want to show you what the picture looks like. Okay, so for this one, it's saying the slope between the endpoints, the algebra slope, which would be just a straight line. Okay, so the algebra slope between the endpoints. And I like to draw I like to draw the mean value theorem and the intermediate value theorem. And for the extreme value theorem, I like to do a number line. Okay, but this one I like to see a picture. Okay, and then what it's saying is there's some spot where the slope is the same. So maybe here, the slope is the same, and that spot is called C. Okay. Okay, so you remember the theorem, it says like there exists a C between A and B. I'm not sure if you saw that symbol. The symbol just means between. So there exists a C between A and B such that f prime of C equals f of B minus f of A over B minus A. Now, there's some conditions, though. So you do have to know your conditions. Okay, the conditions for the mean value theorem is you need to be continuous on the closed interval. That's number one. And number two is you need to be differentiable on the open interval. And then Rolle's theorem adds 3. So for Rolle's, you add number 3, and 3 says that f of b equals f of a. And then you could just use mean value theorem for Rolle if you wanted to. And then this will happen. So if it's continuous, if the function is continuous, and if it's differentiable, this is how it happens. Okay. So that one you used a lot. You had a whole worksheet on. Intermediate value theorem, we teach you in previous math classes, but really it's more in Algebra 2 than anywhere else. Okay, so intermediate value theorem, and there's different versions of intermediate value theorem. So I'm going to give you the most generic version. Okay, so what you have is you have f of a, You still have A. You still have B. Okay, so it looks like the same picture from here to here. So you have those two values. And then intermediate value theorem, where you've normally seen it, is that f of A was below the x-axis. So I'm going to also show you that version. Maybe I'll show you that version right here. So another version of this one is you have your A and your B, and your f of A is below the x-axis. This is the way you learned it in, say, Algebra 2. And your f of B is above the x-axis. And it could be reverse. F of A could be above and f of B could be below. An intermediate value theorem says, and I'm going to do the one on the right, and I'll draw it in highlighter, is it says this line here, which is 0, if f is continuous, then there exists a C in between A and B, such that f of C equals that 0. Okay, so that's how you learned it in the past. So this is intermediate value theorem that you learned in the past. AP ups it a little bit. Okay, so intermediate value theorem on the AP exam doesn't have to be that one's below and one's above. Okay, and this does say that in this one, f of A and f of B is the 0 is between. So this is the Algebra 2 version. Okay, so this also still works. Okay, but the way that this version works, and it only has to be continuous, it doesn't have to be differentiable, so it works on absolute values and so forth. Hold on a second. I'm seeing somebody's question. Not always. The question you just asked me at 4:52, not always. So it gets a little confusing. So I'm going to show you one with an SVA problem. What keywords to know when you're using extreme value theorem? Extreme value theorem is when they ask you for an absolute max or an absolute min. So that's when you're using extreme value theorem. So you're using it all the time. So often. You'll see it often. So it says, what's the absolute maximum? What's the absolute minimum? That's when you're using the extreme value theorem. And then make sure on the AP test you don't abbreviate, because you don't know if they abbreviate the same way. Okay, so actually the intermediate value theorem and the mean value theorem, in certain cases, it's a little bit tricky. Okay, so if you're looking for something for f prime, it might be mean value theorem, but actually it could be intermediate value theorem as well. But normally it's mean value theorem, but not always. So that's kind of what I want to show you. Okay, so intermediate value theorem. Okay, they have a K in here. Okay, so one of the qualifications is f of x is continuous. Okay, and K is between f of A and f of B. Then there exists a C. And then I'm going to show you a real question. Then there exists a C between, well, such that oh, well, not true. Not a such that. There is a C in A and B such that f of C equals K. So you must hit every single value between f of A and f of B. Okay, so let me show you the one that I'm thinking of. The S problem, the V problem. So I'm going to show it to you with a V. And then I'll show you how the one on the mock exam was so confusing. Okay, and then I have another one I want to show you. So there's a few I want to show you. The thing that's interesting is, I wonder if you guys have been seeing them as much in AB as we have in BC, because they took off accumulation functions for AB. And so because they did that, that's where I keep finding a few of them. But there's some in the SBA problems too. So I'll show you some questions that I came across this week that reminded me that I really wanted to do this video. Okay. Okay, so let me show you a case where it might not be known. Okay, so say you're trying to prove that V of C is equal to 0 or a number. So let's just say you're trying to show that V of C is equal to 2. Okay? So let me show you two circumstances where the theorem would work. Now, if there was a situation where you're looking at a graph of V, okay, you're looking at a graph of V, we'll call it V of T. So you're looking at V, and they want you to prove, or how many times does it cross, sometimes like that, how many examples are there of it? Well, and here's your A and your B. Okay, so you want it to be able to hit 2. Now I know V is a slope, but V is also a function value. Okay, so this would be the more unusual type. So if you could find an f of A that's lower than 2, and you can find an f of B that's higher than 2, then you have to at least cross once by intermediate value theorem. I just crossed 3 times. But if you looked at V of C as S prime of C equaling 2, maybe you would like to use the mean value theorem. So this would be, maybe I would use the mean value theorem. And the mean value theorem, if it's a derivative, then you would use it on the non-derivative one. So it would be S of B minus S of A over B minus A equals S prime of C. So it is possible that if you're looking at an S graph or some S data, that to prove something about V, you're going to find the slope between the endpoints, and this slope turns out to be 2. Or 0, sometimes they throw in the 0 there. Or it's possible that you want a Y value of 2 if you're graphing V. Okay, so let me show you some cases of mean value theorem, and then I want to show you some actual examples of where this comes up in a problem. Okay, so one thing that you want to know is you want to know that you can do mean value theorem on different functions. So mean value theorem on F is where you do F of B minus F of A over B minus A. And then I'll do it where the derivative is on this side. So equals F prime of C. So that's the mean value theorem on F. But you can also use the mean value theorem on F prime. So that would be F double prime of C equals F prime of B minus F prime of A over B minus A. You can use the mean value theorem on S. So what would that be? That would be S of B minus S of A over B minus A, which is also called the average rate of change, or this is the average velocity. So sometimes they'll use this in SVA problems. So average velocity, and then what's the derivative of S? Can somebody type it in the chat box? What's the derivative of S? And what's the derivative of S? What's the other name of derivative of S? Exactly. So this could be V of C. Okay, what if you wanted to use mean value theorem on V? That would be V of B minus V of A over B minus A. And then over here, it would be V prime of C. And V prime of C, other name is A. So these are all examples where you can use the mean value theorem on different functions than plain F. What's interesting is you can also use intermediate value theorem in the same ways. So these are the mean value theorems, but if I'm looking at, this is intermediate value theorem, if I had an F prime graph, F prime of X, I could use the K thing to find it. I could use the K thing to find it because A and B being here, not the values though, but when I substitute them in to F, my determination here would be that if F of A is less than K, less than F of B, or vice versa, the B and the A could be in different positions, then there exists a C in the interval A to B such that, except these are primes, such that F prime of C equals K. It's all about which graph you do. So if you decide to do a graph of F prime or they give you enough data on F prime, you can sketch out an intermediate value theorem. Intermediate value theorem is best looked at on a picture. Mean value theorem, not always with a picture, but if you feel like you're trying to prove something about the derivative, then you would use mean value theorem. Okay, so let me find you a problem. Okay, I have a problem specifically. I want you to go to this problem. Okay, so let me copy this again. I want you to go to this problem, and we're going to look at part B. Okay, so we're going to look at part B of this question. I'm not sure you've done this question before. Probably not, because it's an older question, but it was one I gave my HL class. Okay, so go to this question. It's actually an AB question. So find that one on the internet. You can find the one with the scoring guidelines if you want, but don't look at the scoring guidelines, okay? And then we're going to look at part B. Okay, so find the question. And they give the information in a table. I would imagine that for AP Calculus, I was trying to think of questions while you're looking for that question, while you're looking for it on the internet. I would think that they're not going to put a question that you could just put into PhotoMath and it's going to give you the answer, right? Because they don't want you to cheat. So I'm thinking a question with a table makes a lot of sense, because if you show PhotoMath a table, it's not going to be able to figure out the problem for you. So I'm thinking a table makes a lot of sense to do, like where you have to find the slope of the table. You know, maybe you have to do a Riemann sum. Maybe there's a mean value theorem or an extreme value theorem. Not an extreme value theorem usually with a table, probably more like an intermediate value theorem or a mean value theorem with a table. Okay. So have you guys found that question? Let's see. I can find it on here. Oh yeah, let me find it on here for you guys. And we could take a look at it. Oh, you know what? It's one of the ones I assigned to my class. So let me get this for you. I have it right here. Okay. Okay, so it was practice number 8. Let me go into my HL class and grab practice number 8. Classwork number 8. Response number 8. Instructions. Here we go. Okay, so here's the question. And I want to look at B. Okay, so I want to look at B. I'm going to zoom out. Now, I like to graph anytime they give me a table. I like to graph it, not a perfect sketch, but I like to graph at least the idea of the graph and then kind of make them go up and down as needed. Okay, so this is what, 0, 7, and 9, then a little more than 9. Oh, then 7. Oh, that's interesting. Then 4.5, then 2.4, 2.4. Okay, interesting. 4.3. I think I need a better graph of that. Okay, so part B is the one I want to focus your attention to. And then let me go back to my other one so that I can make sure you guys can see that. Hold on. Because I'm on my computer and my tablet. Okay, can you guys see the question? Can you see this question on my tab? I think so, because I can see it. So I think you can see it. Okay. So it says, based on the values in the table, what is the smallest number of instances at which the acceleration of the plane could equal 0 on the open interval? Now, when I look at this specific graph, it's not a graph of A. Okay, so they're asking me about A, but they're giving me a V graph. That makes me feel like mean value theorem, if this problem even makes me think of a theorem. If I was graphing A points and they asked me about A, then I might be thinking intermediate value theorem. And then I have to trap the K. Okay, so in this one, notice that if this was a picture of A, 0 isn't trapped anyway. So if I grab, let's see, grab a different color. Oh, I'm on black. Okay, so just take a look at this. Don't draw this. But if I wanted the V to equal 0, it's never above and below 0. So it would not be a good case. This would not be a case where I could use intermediate value theorem because my K, 0, is not in my region. But that would be if they wanted me to prove that V has to be 0. Okay, so V graph, V information would be intermediate value theorem. Now, on the question on the mock exam, it gave us 2, I believe. It gave us information for V and it gave us the information for A. So we had to deal with both of those. And you didn't know, and we weren't able to figure out which one that it was. Okay, so here, let me get, I think purple's a pretty good color. Okay, so let me erase this K because we're not using that method. Okay, so let me go back to this and black so you can draw this in. And that is here. Okay, so the picture really helps me really understand this question. So when I see a picture, it helps me be able to think of what the theorem is because I'm asking myself, do I want the slope or do I want to know something else about it? So in this case, they are asking me about A, so I'm thinking slope. Now it says, what's the smallest number of instances at which the acceleration could be 0? Okay, so the acceleration, for me, when I'm looking at this problem, is I want the acceleration to be 0 somewhere in between here. Now, the slope, so I'm thinking rolls, which is slope between the endpoints. So mean value theorem. So over here, I'm thinking, okay, they want my acceleration at some point C to be 0. So I'm thinking I can do slope between the endpoints. Okay, so maybe I can use mean value theorem on some interval that I don't know yet. And I want to use intermediate value theorem. So I want V of B minus V of A over B minus A. I want this to be 0. Because if I can make that 0, right, I need the acceleration to be 0. So let me erase this side for a minute. I'm thinking this is the derivative, right? A of C. Or you might call this V prime of C, the way I wrote it in the other one. Okay, so I want V of B and V of A. So I want this to turn out to be 0. So how am I going to force this to be 0? So look at the numerator. So an answer in the chat box. So look at your numerator. Let me change this to yellow. So look at this numerator. Now, how am I going to get this numerator? What am I going to have to put there to make a 0 here? I'm going to change back to my pencil while you guys are answering. So what do I need to make that a 0 there? Because this one, when you look at the scoring guidelines, yes, I need the same velocity. I need them to be the same velocity. Now, I don't need them both to be 0. That's the way we originally learned Rolle's theorem, is they have to both be 0. But there is a flexibility with Rolle's theorem. And this is mean value theorem, but Rolle's theorem is a special case. So if I can find a spot where the V of A equals the V of B, when I subtract them, they'll be 0. So the hard thing about this question is you have to pick the interval. So now look at the picture. If I didn't draw the picture, I might not notice it. Actually, from the table now, I can kind of see it. Look at the table. Do you see those two spots where they're both 7? So what if I said, let's use mean value theorem? I don't know if I can use it yet because it has to be differentiable and continuous and all that stuff. But let's just think of a proposal. If I use mean value theorem from 0 to 15, what's the slope between the endpoints of 0 and 15? Right? The slope between those endpoints would be V of 15 minus V of 0 over 15 minus 0. And V of 15 is 7, V of 0 is 7, over 15 is 0. So if I'm allowed to use mean value theorem on this interval 0 to 15, I just proved that somewhere in between the 0 spot on my graph and the 15 spot, which are supposed to be the same value, the slope between those endpoints, when you draw a picture in between, there has to be at least one value. Now, we don't know whether it's at one of the values already given, but we do need to at least one value at 0. Now, it could go below. It could go wiggles and have more spots, but as to at least have one. And that's what this question is asking about. So this is at least one. And this is just to give you, I mean, if you didn't know your theorems, I think you could still pass your test, but you don't want to be stressed where there's a theorem question and you're like, what should I do? And maybe you apply both theorems. If you're not sure and you're thinking, I think it's a theorem question, try both. Try intermediate value theorem and mean value theorem. Try both of them, and then you could see. Okay, so that's what we'd probably do on the one that was on the mock. So we're going to go back and look at that one too. So mean value theorem on this. Now let's check. To use mean value theorem, that means the thing you're using it on, which in this case is V. So I would have to say V is continuous, and I would have to say V is also differentiable. Now it has to be differentiable on the open interval, and it's continuous on the closed interval. Now, what does it say about this? It says, based on the values in the table, the test plane flies in a straight line with positive velocity. Okay, it's not one of those spaceships that jumps from place to place. Okay, so it is continuous. It doesn't actually say that it's differentiable, which is interesting. But they're kind of saying which ones does it appear to be based on the table. So I'm not real comfortable with the fact that they didn't tell me it was continuous and differentiable. But I guess if you're a plane, you don't make jerky reactions. So I guess that's why they're saying it's continuous and differentiable. Okay, so use mean value theorem on that. So that means there's at least one C value. Well, let me move this so that I can write. I think I can, if I zoom this out, I can still write. Okay. So there's at least one spot between 0 and 15. Okay, so at least one value. C between 0 and 15, such that A of this C value is 0. So there's at least one value between there. And then can you pick out the other spot? If it says it's differentiable, it does imply continuity. That's true. Oh, I found it. Oh, there you go. I was really thinking, oh, look right here. You guys, I didn't notice. Perfect. It says V is differentiable, and differentiable implies continuity. Perfect. Landon, thank you. I don't know why I didn't see that. I was like skimming and I didn't see that part. I was like, I can't believe they didn't tell us that. It was kind of stressing me out. Okay, so very good. Okay, so where's the other spot? Yeah, he says between 30 and 35. Yes, 20 and 30. Look at those. Those y values are the same. So the slope between them, and I want A, so I want the slope, has to also be the same thing. So I would also use mean value theorem on V, not on S, on V, on the interval from 25 to 30. And it says so V is continuous and differentiable, because that's what it said in the instructions. And then you would say V of 30 minus V of 25 over 30 minus 25. Okay, and that's 0. And that has to equal A of C for some value C between 25 and 30. Now, one thing that I've seen in an AP problem before, let me write that bigger. One thing I have seen in an AP problem before is that they had an overlap. So let's say, see this 9.5 here? They had another 9.5, but then you didn't know if the points were the same because of the overlap. But definitely, whatever value you had that was between 0 and 15, any number between 0 and 15 is not the same number as between 25 and 30. Okay, so this is equal to 0 over 5, which is 0. Let me write this better for you. Let me erase this part. And then, so by the mean value theorem, there exists a C between, what is it, 25 and 30? Exists a C between 25 and 30, such that A of C would equal 0. Drawing the picture really helped. You could probably convince yourself, but a lot of my HL students did not get B right at all. Like they got 0 points for it. And there was another one that was like that too. And it was, I believe it was another SVA problem. And then I want to go to the one that was on the mock for both of your classes, because that one was another one too. Which one was it? That one. Okay, mean value theorems. So which is my other one? I believe it was up. I'm just scrolling through my questions because I took notes on the questions so that I could help my students. No, it wasn't that one. Oh, this one. This is annoying. Okay, so this is the other one. I want to take a look at this one. And how are we doing for time? Oh, 10 minutes. Okay, so this is another one. Okay, and you're probably not going to want to, we probably won't do this one right now. Oh, I can show you that. What number is this one? This is number 6. Okay. Let me click here. So you could see, here's another one. So you could practice this one later. Oh, is that the one I just grabbed? Hold on a second. Is that the one I did before? Oh no. So it's also number 3. So this is another one. Okay, and this is part, let me see. This is part, is it part D? Yeah, part D. So let me get to this one. Now don't read the solution, because once you have the solution, everything's so easy. You're like, oh, look, I have the solution. So don't look at the solution. So this is a part D. Okay, but I don't want to look at that one right now. We can look at that one at the end. I want to look at the one that was on the mock. because the one on the mock, I believe they gave you so much information that you could use both. And that's really what I wanted to talk about today. So lots of times back in 2004, 2005, they were using mean value theorem that just showed up out of the blue. And then in the 2011, 2012, 2014, like in the teens, then they started throwing some intermediate value theorem in. Okay, and then now it seems like one of the ones that I saw, it's like now they're showing both in the same problem where you have to choose which one to use. Okay, so just in case, and then that'll make it so you potentially have a better score than you would have before. So let me go into this for you. So you can look up that question just to kind of look and which theorem you feel like you might want to use. Also, drawing it out would be good. If you have any suspect of mean value theorem, intermediate value theorem, extreme value theorem, if you draw a sketch, especially with a table, it will help you. Okay, so I'm going to go to, I should go on my tablet. Okay, so let me go on my tablet. The question was in our mock classroom. So I believe it was here. So I believe it was in the AB and the BC. On the free responses. Remember, I was teaching you how to grade, but that was not teaching you, this is this one, but I was not showing you how to, I didn't show you how to do it. Multiple choice, grading video, live materials for the virtual mock exam. Oh, I think she might have put it under right here. Fix materials right here. Okay, so I don't remember which one it was. So let's just look up this one. So we can flip through and see. I believe it had a table. Oh, this one actually said apply the intermediate value theorem. That's interesting. That's not a bad one to look at too. So this is your mock. 1D talks about intermediate value theorem. Okay. And then I believe there was another one. This one right here. C, 5C. So that's interesting. On the same exam, they're having both of them. Okay, so let me zoom out here so that you can kind of see it. Okay, so the mock exam is a good place to practice these theorems. Okay, but you took the mock exam before you were really an expert at these theorems. Not that you're an expert now, and nor is anybody ever an expert. But this would be a good time if you think you got everything else down to take a look at these. Okay, so and you know what? I can't remember what year this was. So you could start typing up Ben rides a unicycle back and forth on a straight east-west track, and I'm sure you could find the actual question. Okay, but I also post the solution somewhere else. Right, I think I posted you can look at the grading video, but that's how to grade it, not how to do it. Okay, so let's do this one. Let me take a picture. I also saw one that was in a graph given question, one like this. So it was also like that. It was very interesting. I found it very interesting that it showed up on these questions where I wouldn't expect it to. Okay, so we're trying to do part C. I hope you can see that. I can zoom in. So here's the table. Take a picture of it. Take a picture of it so that you can look at it separately if you want, because I'm going to have to zoom out to write on it. Okay, so the thing that's interesting about this one is they gave me the original S and they gave me V. So they usually only give you one. And same thing, maybe a graph given gives you two equations. Okay, so I'm just looking for part C. So it says between 40 and 60, there must be a time. That sounds like there exists. When Ben's velocity is 2 meters per second. So I'm going to do it two ways over here. So the first way I'm going to think is when it tells me velocity has to be 2, I could do that in two different ways. One way I could do it is I could use a V graph, and K is 2. So some V value is above it and some V value is below it, and I could use intermediate value theorem. Or I could say V is really S prime equals 2. So if S prime equals 2, maybe I could do S of B minus S of A over B minus A equals S prime of C. So if the left side turned out to be 2, then maybe this would work. So that's my thought process. Okay, so that's my thought process. So let's see. So now it gave me a region, which is nice. I didn't have to pick my own. So it specifically said 40 to 60. So that would be S of 60 minus S of 40 over 60 minus 40. And I have to figure out what that is. So if it's continuous and differentiable and all those good things, which does it say it is? It says twice differentiable function. That means you can take the derivative twice and there's no problems with continuity. Okay, so S of 60 is B, right? I guess I should use their letter. So I'm going to type over it. So they're telling me B of 60, B, and then B prime. Okay. So this one's the example of the mean value theorem, if it works. But this is more specific. Mean value theorem is harder to get to work because I need to get the exact value 2. For intermediate value theorem, I just have to be above and below 2. I don't have to actually hit 2, so it might be different. Okay, so for this one, B of 60 is 49. B of 40 is 9. And 60 minus 40 is B prime of C. And B prime is V. And that's 40 over 20, which is specifically 2. Okay, so this did work. But what if that slope wasn't specifically 2? What if that slope was, what if this question instead said, when is V 2.2? Okay, so we'll just put a what if. So what if it said, is V 2.2? Well, let's not say that. Let's say 2.9. So what if it said, is V 2.9 in the interval between 40 and 60? I would have done the mean value theorem. So this is a what if. So I would have done this between 40 and 60. So I'm saying, what if this said 2.9 instead? And I would have done this whole right side. Okay, so it looks like this one is an example of the mean value theorem because we hit the exact number. But sometimes you don't hit the exact number. So if I did this side right here, oops, I did not mean to erase that. Oh, good, I have a back button. Okay. Oh, I didn't mean to hit the eraser. I was trying to hit the highlighter. Okay, so this side right here, this is mean value theorem. But what if I did the 40 and the 60 and I was trying to get 2.9 and I got 2? Well, then it wouldn't have worked. But on the intermediate value theorem side, if they had changed that number on me, it would have worked. Because it says that at 0, oops, let me change back to the regular pen color. At 0, I'm at 2. Oh, so now I'm trying to get 2.9 though, right? So hold on. In this one, let me show you the way that didn't work, and then I'll show you the 2.9 way. So that's 2, and then it was what? 2.3, 2.5, 4.6. So if I look there, definitely between 40 and 60, and actually nowhere am I guaranteed to hit 2. Now I am guaranteed to hit every value in between. Every value in between these, because it's continuous, would have to be hit. So if I was talking about 2.2, it has to hit between 2 and 2.3. 2.4 has to hit between 2.3 and 2.5. 2.9 has to hit between 2.5 and 4.9, 4.6. So there's a lot more flexibility here. I have to hit 4, I have to hit 2.9, I have to hit 3.1. I don't have to hit 2 because they didn't design the problem that way. Okay, but if it was 2.9 and you drew a picture of V, intermediate value theorem, you have to draw the picture of what you're looking for. And here is 2.5, and that's at 40. And then at 60, it's 4.6 right here. Where's 2.9 compared to those y values that I just graphed? Isn't it between? Isn't 2.9 right here? So if 2.9 is right there, intermediate value theorem says that I have to cross it. How, if you're continuous, can you jump from 2.5 to 4.6 without crossing it? Okay, so I just wanted you to be alert. That's why I made this video. So, and the other teachers were thinking the same thing sometimes, is these theorems, you just never know. They're a little odd. So I would definitely try the one that I have written here. Try it and then look up the solution. I don't believe it says which theorem. If it says which theorem, you're set. But you can do the theorems on different functions than f. So if you look at the formula kind of at the beginning, you'll be able to see that as well. Okay, so this 2.9 was a what if. Okay, so this was a what if it was 2.9. It's not, it's 2. So they wanted you to use mean value theorem. And they had you use extreme or intermediate value theorem on a previous question, which I want to go back to. So this right here was what if. This isn't the actual question, right? This was what if it was a 2.9. An intermediate value theorem would have worked and not mean value theorem. And how you would have worded it is you would have said, since k equals 2.9 is between v of 40 equals 2.5 and v of 60, which equals 4.6. And since v is continuous, you just need continuity to do intermediate value theorem. Then by intermediate value theorem, it's not liking me to put my I right there. Okay, so by IVT, that looks like TVT, but that's actually an I. Let's see if I can erase the top of the T. There you go. So here we go, IVT. But yeah, I would use the whole theorem name. Then by IVT, there exists a C that's between 40 and 60, a C between 40 and 60, such that f of C equals 2.9. No, see, that's the thing I've been noticing over the last couple of years, Landon, is that like when I saw this question, I don't know if you guys saw my reaction, but if you go back and watch this video, when we were doing this video and I was doing the corrections, I was thinking, hey, you could use intermediate value theorem, or somebody else said it. And I was thinking this may not work. And so this is one of the first problems I've seen where they gave you enough information for both. So there's no keyword here. Like I'm saying, if it was 2, I would have used mean value theorem. If it was 2.9, I would have used intermediate value theorem. It has to do with the values that they gave me. So if the slope doesn't work for you, then maybe a graph of the value that you're actually looking for, which in this case was v, would help. And you want to just have flexibility. I can apply intermediate value theorem on anything. I can apply it on V. I can apply it on A. I know the other student said, I don't want to say her name, but the other student said, oh, it's easy for me to tell the difference between mean value theorem and intermediate value theorem. I'm telling you that this question, there's no way to tell the difference except the value of the number. And I would have had to use mean value theorem to make sure it was 2. If not, I would have had to use extreme value theorem. And then in this case, not extreme value theorem, intermediate value theorem. And maybe neither one works. So in this case, what if it had asked me about the V equaling 1.9? So say it said V equals 1.9. I would have said, well, intermediate value theorem. So hold on, let's see. Mean value theorem gives me 2, but I'm looking for 1.9. and then I draw a picture over here, my picture over here in green, it's never going to, it might not hit 1.9 because it doesn't necessarily go below. So maybe I have to say neither theorem applies in this situation. Yeah, so I mean, I wish there was. I don't think passing the AP test is going to be dependent upon theorems. But, you know, if you want to get the 5, you don't want to be in a situation where you see a problem and then you don't know how to do it, especially on AB. I believe it's going to be on BC too, but on AB specifically, since they took out all the integrals or most of the integrals, they took out so much. How can they make the difference between who gets a 4 and who gets a 5? Maybe it's going to be based on theorems. Okay, and on this one specifically, this year, whatever year this was, I forgot what year, so I have to look back. But I wish I remembered the year. But this had 2, because look, this one actually said apply the intermediate value theorem. So look on this one. Okay, it said apply the intermediate value theorem on this one. So let's just see what they're talking about. So apply the intermediate value theorem on the function d on this interval to justify there exists a time at which the heights of the water are changing at the same rate. So a same rate means these are the same. So they're wanting to prove that, and let me change it to a pen. Okay, so changing at the same rate, if I wanted M and S to be the same, then I would need D to be 0. So I need D of C to be 0, which might mean that I need the prior to D, and then D is the derivative if I was using mean value theorem, right? But this isn't mean value theorem, so this is I have a graph of D, because they're saying it's intermediate value theorem. I need a graph of D, so I need to know what happens at 0 and what happens at 60. So if I substitute 0 in to M prime, so I need D of 0, not M of 0. So I need D of 0 and I need S of 0. D of and I need D of 60. And this is a calculator question, so you could use n derived to find those derivatives. So, but I believe this derivative is 330 over 400. And then I don't know what the derivative at 60 would be, but this is a positive number. So I'm going to assume that this is a negative number if I took the derivative of those. Oh, it also has me subtracting S prime of t. Oh, so I don't really know. I would have to actually do this question. Okay. But basically, they want me to find these two. So just because I know how intermediate value theorem works, because I'm trying to prove that K is 0. Okay, so since I'm trying to prove that K is 0, that means that one of these values, 0, is above and one of the values is below. I don't know which one. Okay, but if this is your K, you have to have one of your values be above and one of your values be below, and then every K is hit if it's continuous. So you'd have to find these out. And since K is 0, it's like the algebra 2 version where I just need one positive and then one negative. Because I need to trap 0. In the other case, in the problem I was just showing you where I needed to trap the 2.9, the trapping the 2.9 is a different situation, right? This is trapping 0, so one's positive, one's negative. If I want to trap 2.9, maybe one's 3, one's 2 and one's 3, and that's fine. So it depends on the situation. Okay, so they're a little tricky. I would go back and do this one. Go back and try this one. Let me get to this question, but go back and try this one. I found it in the mock information, and then you could go back. It's number 1, so the solutions, you could see what the solutions give you. Was S up here? Oh, there was S. Oh, you guys, S prime's up there. Okay, so this was the S prime. So if I plug 0 into that, I get 1.5, 1.5, that minus 1.5. Oh, okay, so I think the D of 0 was actually negative. So the D of 0 was negative and the D of 60 is positive if you actually work it out, I believe. So this isn't necessary. This might be a good question. Okay. So remember, you want to know all the other stuff. You know, you don't have to be an expert at every single thing, but if you want a 5, since the test is short, you know, and they did say, I think somebody told me that they said that there were probably more questions that you won't have time to do them all, which kind of is good because that's how I do my HL class all the time. If you make all like more questions, then you don't have to get all of them right, but at least you get to pick a little bit better. So don't let it stress you out if there's a certain part that you don't know how to do. And if you're like, oh, I think that might be a theorem question, go to the rest and then go back to the theorems at the end when you know that you have enough time. So anyway, okay, so interesting stuff. I do have some other questions that were mean value theorem. So if anybody wants to know, I could post those. I could post those in both classes because all I was doing yesterday and the day before is grading all my HL free responses. And as I kept going through, the part they kept missing was the ones on the theorems. And they haven't seen that for a couple of years. But still, no one's ever an expert. Okay, so keywords, you can't really tell the difference. I guess the there exists used to make me think of mean value theorem. And then over the last few years, it's made me think of intermediate value theorem. And now it makes me think of both, and I might have to do both. But this is kind of a good point here. If you look at this, if you're using, say, intermediate value theorem, basically your picture is that K is here. And if you want to do intermediate value theorem on A being acceleration, we'll put A for acceleration. You have A and B, you need one value to be below and one value to be above. K, the value that you're trying to prove that acceleration at this value C equals this K value. Okay, so your picture itself, if this is an S graph, then the K is here, and here's your A, here's your B. Maybe the A is above, maybe the B is below, and that's going to show that you actually can hit that K value that you want to hit. Okay, let's see. I have a chat question. The practice is available online is 45 minutes. I think so. I saw a BC one. I put it in my, you know what? I never really checked it, but I put it in my class. So let me check. Let's check what it was called and where it was, and there might be an AB one as well. Let's check the BC one that I posted the other day. Okay, so let's see. So what it told me, so let's go into my HL class, and this will answer your question, because if they have one for BC, they definitely have one for AB. Okay, so I was here, live lesson on theorems, free response, BC free response, print out the chat sheets, print out the thing you need to know, watch, take notes, and screenshots. Okay, so what's this? This is, yeah, look at what this says. It says AB Calculus BC Practice Exam 2020. Now, Landon, are you in AB or are you in BC? Okay, but let's just check. So let me click on the BC one. And let's see. So it says practice exam format. So let's see. Look at, there's only 2,000 views. Oh, you guys, I don't know who Michelle Kreml is. You can download a copy of the exam here. Interesting. No. Okay, I guess so. Oh, look. Wow, this is cool. Now, you guys, this looks like College Board. Is it written as College Board? The type style looks like College Board. Gosh, where did I see this? That's so interesting. This is almost exactly what I was thinking was going to be on the test. Interesting. It looks like College Board's type. It says, look, right there. AP calc. I don't know. Anyway, so let's see. Let's look at Michelle Kreml. Practice exam BC format. Okay, thank you, Michelle Kreml, but I don't know if it's official. It wouldn't hurt to practice anyway, right? But my question to Michelle Crummel here is, do we have an AB one? BC times, oh, look right here. AB right here. This is advanced placement, and it says AB timed AP exam practice 1. A virtual lesson. Practice number 2. It looks like there's multiple practice. Yeah, look. Practice helpful documents, what the exams look like. We already saw that. Optional self-paced research practice, no. At-home online tests. Yeah, see, they have mock exams. Look at this right here. This is on the College Board website. This is on the College Board. This is on the College Board YouTube, right? Aren't I on the College Board YouTube? Yeah, look, advanced placement. That's College Board. Okay, and they're saying that there's a timed AP practice number 1. And then an AP practice number 2. That'd be cool. So find that. If you guys find that and you see it, you should do it, right? There's those 2 videos right there. Right? So then they're going over the questions, right? Yeah, but don't look at those. You want to optional cut and paste type, hit submit. Are they going like upload mock exam? So see, there's the mock exam sample questions. Maybe you could fill the full link in the video. Oh, time left for student to submit work. So these videos are them. You watch them and you do them and you practice them. Oh, you guys, this is too cool. Okay. So let me hit share, copy. We also need this one, right? We need the practice number 1. Dang, you guys, this is awesome. I'm gonna have my students practice this for BC2. Okay, so let me hit share here. Hey, it's lost. Okay, hold on. It's not really lost. Right here. Okay, let me stop this video and then I'm gonna start a new video. So I'm gonna stop this video. This is the end of the theorems video.